Sometimes problems will ask you to find the distance between points without using a coordinate grid. Now we're actually going to start with using the coordinate grid so that you can see how we derive the shortcut to be able to do this without graphing it out. So let's look at what this looks like when we graph these points. So the distance between the points 2, 1 and negative 2, 2. Normally if we had this picture, we would connect the lines because the shortest distance between 2 points is always a straight line. And that would become the side of a right triangle, which we would then draw in. And from here we could just count the distance on our graph. 1, 2, 3, and 1, 2, 3, 4. Those become the legs of our right triangle because they make the right angle, and our diagonal, the longest side, the hypotenuse, would be our C. Now what I want you to notice is we're going to actually look at the x values between these 2 points first. So we're going to look at the x values negative 2 and positive 2. If we were on a number line and we were trying to find the distance between these two numbers on the number line, the distance between negative 2 and 0 is 2, and the distance between 0 and 2 is also 2, which means when we combine these two to get the entire distance here, it equals 4. Notice that is the same length as one of our legs of our right triangle, and it's the leg that follows the same direction as our x-axis, the horizontal direction. If we look at our y values, we have negative 2 and positive 1. If we do the same thing from negative 2 to positive 1, so negative 2 to 0 again is 2, 0 to 1 is 1, so all together that would be 3. Notice that is our vertical length. Again, we're using our y coordinates, and that's the direction of y for this leg of our right triangle. So if I did not have the coordinate plane, but I knew the points, negative 2, and 2, 1, I could just say, well, how do I get from negative 2 to 2? Well, that distance is 4. That's my first leg. How do I get from negative 2 to positive 1? That would be a distance of 3. Those become the legs of my right triangle, so that's my A and my B. So I now have A squared plus B squared equals C squared. 4 times 4 is 16. 3 times 3, 9. Again, add those, we get 25. Undo the squaring by square rooting both sides, and I would get that C is equal to 5 without having to draw anything on a graph.